Back in 1964, I had a chemistry teacher who was quite possibly the most miserable man on the planet. We called him Mr. Unhappymon. He spent his days lecturing to the chalkboard, his back turned to the class, his face frozen in a permanent, joyless scowl. He didn't just seem to hate the subject, he seemed to resent the very fact that he had to exist in the same room as us. But one Tuesday, about 10 minutes into the lecture, the machine broke. He stopped writing, turned around, and gave us this slow, mischievous grin. A minute later, he was actually chuckling. Then, right there in front of everyone, he reached into his white lab coat, pulled out a metal flask, and took several long, heavy gulps. We were stunned. We thought we were watching a man have a mid-morning breakdown, or at the very least, getting drunk on the job. For a few minutes, he was the happiest guy in the room, glowing with this bizarre, uncharacteristic energy that felt almost like a party. But then the grin just evaporated. He looked at us with that old familiar irritation and said flatly, "I'm diabetic, my blood sugar dropped. That was glucose." And just like that, the joy was gone. The old Mr. Unhappymon was back, just as bitter and stern as he had been 30 seconds prior. That sudden, jarring shift from giddy euphoria back to a cold scowl left the room silent, but it pointed to a much deeper, more uncomfortable truth about how we view the human mind. We've been told for decades that our feelings are the result of chemical balances, that molecules dictate our moods, and that joy or sadness can be turned on by the right substance. But watching Mr. Unhappymon made me realize the exact opposite. Those chemicals didn't create a new emotional experience for him, they just temporarily broke the system that allowed his real experience to unfold. It raises a question that most of modern psychiatry is afraid to ask. What if the relief we get from changing our brain chemistry isn't actually healing at all, but just a very convincing form of impairment?
Yeah. The deeply jarring nature of that story really shatters a foundational myth of modern medicine. And honestly, the mission of our deep dive today is to just completely dismantle the chemical imbalance theory of the human mind. We are going to explore the profound biological messiness that actually drives our behavior. And we'll reveal how your environment and your life experiences dictate your biology, not the other way around.
Right, because for anyone listening, you've probably heard this theory 1,000 times.
Absolutely. But to really grasp how society arrived at this fundamental misunderstanding, we have to look at the exact origins of this narrative. Because, it didn't start as a proven scientific fact. It literally started as a guess.
Yes.
Back in 1965, a researcher named Joseph Schildkraut published a paper in the American Journal of Psychiatry. And in it, he put forward what he called the catecholamine hypothesis of affective disorders.
Careful.
Yeah, but this was the absolute genesis of the idea that depression, anxiety, and other emotional states were caused by a deficit of specific neurotransmitters in the brain.
Okay, let's unpack this right out of the gate, because timing is everything here for you listening. 1965. This is an era when psychiatry is desperately trying to establish itself as a hard medical science.
Exactly. They were trying to move away from the old, psychoanalytic models of Freud.
Yeah, they wanted something they could physically measure under a microscope. So Schildkraut puts this idea out there, but what did the actual data look like at that exact moment?
Well, that is the most astonishing part of this entire history. At the exact moment he published that paper, there was absolutely zero empirical evidence to support or disprove the theory.
Zero. Like none at all.
None. It was purely speculative. And to his credit, Schildkraut actually knew this. He explicitly warned in that very same paper that his hypothesis was, and I quote, "at best a reductionistic oversimplification of a very complex biological state."
Wow. So he was essentially saying, hey, here's an interesting thought experiment, but please do not treat this as the definitive answer to human suffering.
But of course, the scientific community did exactly what he asked them not to do.
Right. They just took this reductionistic oversimplification and ran with it. It reminds me of someone sketching a rough map on a napkin at a bar, and suddenly the whole world is using it to navigate the ocean.
Because that speculation inspired a generation of researchers to embark on this desperate, decades-long hunt to prove the hypothesis. They really wanted to find the missing chemical.
And what were they looking for initially?
Well, the focus quickly shifted to serotonin. By 1969, a researcher named Malcolm Bowers at Yale University conducted one of the first major investigations. And you have to understand the lengths they went to for this.
Because you can't just crack open a living human brain to check the serotonin level.
Exactly. So what he did was extract cerebrospinal fluid from 8 depressed patients through lumbar punctures.
Wait, spinal taps?
Yes, spinal taps. He was specifically looking for a substance called 5-HIA.
Okay, let me stop you there to make sure we are all on the same page. 5-HIA. What exactly is that, and why on earth are we looking for it in spinal fluid if the problem is supposed to be up in the brain?
So 5-HIAA is a metabolite of serotonin. When your brain uses serotonin, it breaks it down into waste products. And 5-HIAA is that primary waste product.
Okay, so it's the trash left over after the brain does its thing.
It gets washed out of the brain and down into the cerebrospinal fluid. So the logic Bowers used was fairly straightforward. If depressed patients truly have a serotonin deficiency in their brains, their spinal fluid should show significantly lower levels of this exact waste product.
So for you listening, it's like trying to figure out how much gas a car is burning by measuring the exhaust coming out of the tailpipe. If the engine is starved for fuel, there shouldn't be much exhaust. So he does these painful spinal taps on 8 patients. What did the tailpipe show?
Well, Bowers found that the levels of 5-HIAA were slightly lower, but the difference was not statistically significant.
Meaning it was just statistical noise.
It wasn't proof of anything. And, this was just the first of many, many scientific dead ends. The failures to prove this theory just cascaded throughout the 1970s and 1980s.
Did anyone else try to replicate it?
In 1971, researchers at McGill University, led by R. Popesky, attempted to replicate the search for a serotonin deficiency. They found absolutely no statistically significant difference in 5-HIAA levels between depressed patients and healthy controls. None. And even more damning, they found absolutely no correlation between the levels of these metabolites and the severity of the depressive symptoms.
Really? So you could have a patient who is experiencing the most profound, debilitating, bedridden depression imaginable, and their serotonin exhaust levels would look exactly the same as someone who was perfectly content with their life.
Exactly. I mean, if the chemical imbalance theory were true, the most severely depressed patients should have had the lowest serotonin levels. But the data just completely failed. Yeah. And then, in 1974, Joseph Mendels and Alan Fraser at the University of Pennsylvania reviewed all the accumulated evidence regarding brain biogenic amine depletion.
And what was their conclusion after looking at all of it?
After looking at years of data, they definitively concluded that the depletion of brain norepinephrine, dopamine, or serotonin was in itself insufficient to account for the development of depression.
So by 1974, which is less than a decade after the napkin sketch theory was proposed, the scientific community is already hitting a massive work wall.
A huge wall.
But they didn't stop there, did they?
No, they just kept trying to force the puzzle piece to fit. By 1984, the National Institute of Mental Health, which is, the premier authority on this in the United States, conducted a major study led by investigator James Moss.
Okay, so the NIMH gets involved too.
They took a massive step back and looked at the 5-HIAA levels again. And they discovered that the levels varied wildly among depressed patients.
Wildly in what way?
Well, some had low levels, sure, but some had perfectly normal levels. Some severely depressed patients actually had elevated levels of serotonin metabolites.
Wait, so they had too much serotonin exhaust. That completely inverts the entire theory.
It shatters it entirely. The NIMH researchers definitively concluded in 1984 that elevations or decrements in the functioning of serotonergic systems are not likely to be associated with depression.
Oh.
So by the mid-1980s, the top scientists in the field had thoroughly debunked the association. The data was in. The serotonin deficiency theory was practically dead in the water.
But hold on, because if I walked out onto the street right now and asked 100 people what causes depression, 99 of them would tell me it's a serotonin deficiency.
Oh.
Right, so if the National Institute of Mental Health knew this was false in 1984, how on earth did this narrative survive, let alone become the dominant cultural understanding of the human mind for the next 40 years?
Because, simply put, the narrative was incredibly profitable. The persistence of the chemical imbalance theory, despite decades of contradictory evidence, is really a testament to a highly successful marketing pivot.
A marketing pivot?
Yeah. In the 1990s, the pharmaceutical industry began heavily promoting a new class of drugs called selective serotonin reuptake inhibitors, or SSRIs.
Hey, we all know that acronym.
Right. And to sell these drugs, the public was sold a compelling, highly mechanistic story. They were told that they had a broken brain, a specific chemical deficit that required a specific chemical fix.
Much like a diabetic requires insulin to manage their blood sugar, like Mr. Unhappyman in my story.
Yeah.
Okay, this is where we really need to break things down. Selective serotonin reuptake inhibitor. I mean, it sounds incredibly precise. It sounds like a laser-guided missile for your brain chemistry. For anyone listening who has heard that acronym 1,000 times but never actually had it explained to them, how are these drugs supposedly working in the brain?
So to understand the intended mechanism, you have to picture a synapse. This is the microscopic gap between two neurons in your brain.
Right, the little space where they communicate.
Exactly. When one neuron wants to send a signal to the next, it releases neurotransmitters, like serotonin, into that gap. The serotonin floats across the gap, binds to receptors on the second neuron, and passes the message along.
Okay, message received.
But then once the message is sent, the first neuron acts like a vacuum cleaner. It sucks the leftover serotonin back up out of the gap to be recycled. This vacuuming process is called reuptake.
So neuron A spits out serotonin, neuron B catches it, and then neuron A vacuums up whatever is left floating in the gap.
So an SSRI is designed to block that vacuum cleaner. It inhibits the reuptake. By plugging up the vacuum, more serotonin is left floating in the synaptic gap for a longer period of time. So the pharmaceutical narrative was simple. You are depressed because you don't have enough serotonin in your synapses. Our drug blocks the vacuum, increasing the serotonin, thereby fixing the imbalance and curing your depression.
And when you explain it like that, it sounds incredibly logical. I mean, it's brilliant marketing. It takes this terrifying, overwhelming, complex experience of human despair and reduces it to a basic plumbing problem.
Right, just fixing a leak.
Yeah, your serotonin levels are low, we're just topping up your tank.
Oh.
But based on the data we just talked about from the 70s and 80s, that plumbing problem didn't actually exist in the first place.
And, the definitive, absolute dismantling of this theory finally arrived quite recently with the publication of a comprehensive umbrella review in 2022.
Oh, 2020.
Yes. This was by Joanna Moncrief and Mark Horowitz at University College London. Now, it's crucial to understand what an umbrella review actually is.
Right. It's not just a standard trial.
No, this wasn't just a single new experiment with a few dozen people. This was a systematic collation of decades of research, encompassing tens of thousands of patients. It was effectively a study of all the studies.
The ultimate final word on the subject. So what exactly did they look at?
They looked at everything. They looked at serotonin and its breakdown products in blood and brain fluid. They examined the physical structure of serotonin receptors. They looked at the serotonin transporter protein, the vacuum cleaner itself.
Did they look at genetics?
Yes. They even looked at massive genetic studies comparing the frequency of serotonin transporter gene varieties between depressed and healthy individuals. They're trying to see if depressed people were just genetically predisposed to have faulty serotonin systems.
Okay, and the results across all those thousands of data points?
Zero difference. Across all these metrics, there is no evidence of a serotonin deficiency in depressed individuals. None. The review definitively proved that the foundational premise of the chemical imbalance theory is biologically false.
Wow. Huge.
But the review also revealed a highly concerning paradoxical finding. When they looked at patients who had been on long-term antidepressant medications, some evidence suggested that the prolonged use of these drugs might actually lower the brain's overall serotonin concentration over time.
Wait, let me make sure I am hearing this correctly. The drugs that were sold to the public as the cure for a supposed serotonin deficiency might actually be causing the brain to produce less serotonin in the long run.
Yes, because the brain is a dynamic homeostatic system. Exactly. If you artificially flood the synapses with serotonin by blocking the reuptake pumps, the brain eventually recognizes the artificial surplus. So it compensates by down-regulating its own natural production and reducing the number of active receptors.
Okay, let's unpack this with a real-world analogy so you can visualize this. If you have a terrible headache and you take an aspirin and 20 minutes later your headache goes away, that is fantastic. But that doesn't mean your headache was caused by an aspirin deficiency in your brain.
Right.
You wouldn't say my brain's aspirin levels were unbalanced. You'd just say the drug suppressed the symptom of the pain. So why did the entire medical establishment institutions like the American Psychiatric Association and the general public buy so heavily into the idea that depression is literally a serotonin deficiency when the scientists themselves couldn't find the proof?
Well, the medical establishment and the public accepted this premise because of a critical, really deliberate shift in how we talked about these chemicals.
What kind of shift?
It was a transition from what we call a drug-centered model to a disease-centered model.
Friends.
Historically, throughout most of the 20th century, psychotropic drugs were correctly understood under the drug-centered model. They were seen as chemical agents that created altered, artificial physical and mental states.
Like altering your baseline.
For example, early psychiatric medications developed in the 1950s were accurately called major tranquilizers.
Right, because that describes exactly what the drug does to you. It tranquilizes you. It slows you down.
They were understood to induce a state of emotional indifference and lethargy. If someone was experiencing extreme manic agitation, a major tranquilizer would artificially suppress their nervous system. But it wasn't curing a tranquilizer deficiency. However, in the 1980s and 90s, the new generation of drugs was rebranded. They needed to sound like precise medical magic bullets targeting a specific disease process. So instead of calling them tranquilizers or state alterers, the industry called them antidepressants or anxiolytics.
Oh, wow. That is a massive psychological shift. I mean, if you hand me a pill and say, this is a tranquilizer, I know you're giving me a chemical to temporarily numb my reaction to the world. But if you hand me a pill and say, this is an antidepressant, you are telling me I have a biological disease called depression, and this pill is the specific antidote for it.
Exactly. And by changing the name, the industry masks the reality that these substances likely act as broad, emotional numbing agents. They blunt both the extreme lows of despair and the extreme highs of joy.
They just compress your emotional range.
They create a synthetic emotional ceiling and floor. And what's wild is that in clinical trials, the actual efficacy of these drugs is often barely distinguishable from active placebo.
Really? Just placebos with side effects?
But the new terminology created a powerful illusion of biological specificity. As Princeton professor Andrew Scull brilliantly noted, this terminology is basically biobabble.
Biobabble.
Yeah, it's a simplistic biological reductionism that sounds highly scientific, but is actually as deeply misleading as the vague psychobabble of the psychoanalytic era it replaced.
Which brings us to a really uncomfortable realization. If the chemical imbalance theory is false, if the brain is not a simple machine with a fluid reservoir that can be neatly balanced with a chemical top-up, then what is actually going on up there? We have to completely tear down this ideal mechanistic view of the brain and look at how it actually operates. Because the reality of the human brain is that it is a biological masterpiece of messiness.
Messiness is the perfect word for it.
It doesn't run like a pristine computer processor. It actually thrives on noise, chaos, and continuous environmental adaptation.
Right. And the sheer incomprehensible scale of the brain is the first thing that invalidates these simplistic chemical models. I mean, we are talking about an organ that contains approximately 86 billion neurons.
86 billion?
Yes. And those neurons are making over 100 trillion synaptic connections. Classical neuroscience models, the ones that really influenced the early chemical theories, they attempted to treat neurons as uniform, predictable, identical units, like bricks in a wall.
But they aren't.
No. Modern research reveals massive morphological and electrophysiological heterogeneity.
Okay, let's translate that for you, the listener. Morphological heterogeneity.
Basically, the cells in your brain don't all look the same, and they certainly don't act the same. If you were to zoom in with a microscope, what kind of diversity are we actually looking at?
It is like looking at an old-growth forest compared to a manicured lawn. You have pyramidal cells, which possess vast, sprawling dendritic arbors.
Like branches.
Right, think of the root system of a massive ancient oak tree, branching out in 1,000 directions. These cells are designed to integrate thousands of different inputs from all over the brain simultaneously.
Okay, so big, slow, integrating cells. Yes. But right next to them, you might find cerebellar granule cells, which are tiny, compact, and prioritize incredibly rapid, localized processing. They are basically the fast-twitch muscles of the neural world.
So you have these giant, slow, deliberative oak trees and these tiny, lightning-fast processing units all packed in together. And they aren't firing in a neat, orderly sequence, are they?
This structural diversity means the brain is inherently constantly noisy. Neural signals are continuous, stochastic, and fraught with random fluctuations.
Stochastic meaning random, right.
Even the release of neurotransmitters at that synaptic cleft we talked about earlier, it isn't a guaranteed deterministic event, it is probabilistic.
Wait, so it doesn't always happen?
No. Sometimes an electrical pulse reaches the end of a neuron and a burst of serotonin is released. Sometimes the exact same pulse arrives and nothing happens. There are constant metabolic fluctuations, temperature changes, and synaptic jitters.
Man, if an engineer built a laptop that operated like that, where sometimes a keystroke typed a letter and sometimes it didn't, and the internal voltage was constantly fluctuating randomly, they would be fired immediately.
Sure.
In classical engineering, that level of noise is a catastrophic flaw. The machine is broken. But in the human brain, this messiness isn't a bug. It's the ultimate evolutionary feature, isn't it?
It is the absolute foundation of our survival. The brain utilizes a fascinating phenomenon known as stochastic resonance.
Stochastic resonance.
Yes, this is a counterintuitive mechanism where the addition of random noise actually amplifies weak signals.
Wait, stochastic resonance. Let me make sure I am grasping this because it sounds totally backward to me. If I am trying to listen to a weak signal, like, say, trying to tune into a faint radio station static makes it worse. It drowns out the music. How does adding noise in the brain make a signal clearer?
It's a brilliant paradox of physics and biology. So imagine you have a tiny ripple moving across the surface of a pond.
Okay, a tiny ripple.
That is your weak signal. Maybe it's a very subtle pattern in your environment, like a faint visual cue or a complex social dynamic you were trying to parse. Now imagine a sensor just above the water level that only triggers if the water splashes up to touch it.
Right.
The tiny ripple alone isn't tall enough to reach the sensor. It just passes by undetected. But if you add random noise to the pond, say the chaotic splashing of rain hitting the surface, those random splashes combine with the underlying wave of the tiny ripple. Right. Suddenly the combined height of the ripple and the random noise is enough to push the water up to the sensor. The random noise literally lifts the weak signal over the threshold of detection.
That is incredible. So the static in our brain, the random firing, the chaos, is actually what allows us to notice subtle patterns in our environment that would otherwise be completely invisible to us. The noise is literally the engine of intuition.
Exactly. The noise is the driver of adaptability, creativity, and signal detection. It prevents the brain from getting locked into rigid, repetitive loops. And this completely redefines our understanding of what neurotransmitters like dopamine and serotonin are actually doing.
Because they aren't just fuel.
No, they are not static fluids in a tank that can be imbalanced or topped up. They are broadcast neuromodulatory signals.
Let's give you a way to visualize this. Think about a massive sports stadium filled with 100,000 fans. That's your trillion synapses. The game is happening on the field. Suddenly, one player makes a brilliant game-winning play. How does the player know they did the right thing? The coach on the sidelines blows a whistle and yells out over the loudspeakers, broadcasting a signal across the entire noisy stadium. Again, that coach on the loudspeaker, that is your dopamine and serotonin. They aren't the players. They are the context-dependent feedback.
These neuromodulators operate by providing feedback based on complex interactions with the environment. When you encounter a reward, a punishment, or a highly novel stimulus in your life, these chemicals are broadcast across wide neural networks to solve what computer scientists call the credit assignment problem.
The credit assignment problem.
Imagine you're learning to ride a bicycle. You make thousands of tiny muscle twitches every single second. Suddenly, for 3 seconds, you achieve perfect balance. The credit assignment problem is the brain asking, out of the billions of synaptic connections firing right now, which specific ones were responsible for keeping us upright?
And how does it answer that?
The neuromodulators like dopamine and serotonin wash over the brain in that exact moment, highlighting the synapses that were active, tagging them and saying, strengthen this pathway, this action worked. They guide learning and adaptation in real time.
So they are actively, physically wiring the brain based on what is happening to us in the real world.
The brain's architecture is never fixed. It is governed by experience-dependent plasticity. The brain physically diverges and wires itself based on the specific emotional and environmental experiences of the individual.
Give me an example of that physical change.
Consider the orbitofrontal cortex. This is a region of the brain critical for emotion regulation and complex social decision-making. When an individual grows up in an environment characterized by warmth, safety, and secure attachments, this region physically grows. It develops optimal, dense connectivity.
And what happens when the environment is the exact opposite? What happens when a person is subjected to chronic adversity?
Well, the brain adapts to that reality as well. Chronic exposure to negative emotions, threat, and stress hormones, like cortisol, actively impairs neurogenesis.
Which is the birth of new neurons, right?
Right. It impairs neurogenesis in the hippocampus, which is vital for memory and learning. It also actively weakens the prefrontal cortex's inhibitory control over the amygdala, which is the brain's fear center.
So it's preparing for danger.
Exactly. The brain literally shapes itself to become hypervigilant because the environment demands it for survival. Furthermore, the brain employs a deliberate strategy of sparsity.
Sparsity, meaning it doesn't use everything all at once.
Right. At any given moment, the brain employs a very small set of neurons to establish actual connections. In machine learning, if you train a computer on a very narrow set of data, using all its processing power. It memorizes that specific data perfectly, but it fails completely when it encounters something new.
It's too rigid.
Exactly. This is called overfitting. The human brain avoids overfitting through sparsity and noise. It ensures that you adapt perfectly and dynamically to the unique, messy, unpredictable life you are actually living, rather than locking into rigid, inflexible patterns.
This brings up a massive, profound question. If the brain actually relies on this internal noise, this chaotic electrophysiological dynamic, and this extreme sensitivity to function properly, to fuel creativity, and to wire itself to survive, are our attempts to artificially smooth out or numb that noise with psychotropic drugs actually paralyzing our brain's natural ability to learn and adapt to our environments?
That is the core neurological concern with long-term psychotropic use. Numbing the noise actively prevents the brain from utilizing correlation-driven plasticity.
Because you've turned down the volume on the feedback.
Right. The brain requires that stochastic noise, and it requires those sharp, sometimes painful emotional signals to navigate the environment and rewire its synapses. Psychotropic drugs do not correct an underlying imbalance. They artificially suppress the vital, messy feedback loop between the brain and the external world.
So by blunting the pain, we are also blunting the GPS system that tells us we are in a dangerous or unhealthy environment.
Exactly. By dampening the electrophysiological noise and blunting the neuromodulatory broadcast signals, these drugs impair the brain's ability to update its predictive models. Wow. The individual taking the medication may feel less acute distress in the short term, but this relief comes at an immense cost to cognitive and emotional adaptability. The brain's machinery for processing reality and learning from it is temporarily paralyzed.
Because the brain perfectly adapts to its environment, we have to stop looking inside the skull for the source of human distress. And we have to start looking at the world around the individual. Let me paint a picture for you to show exactly what this looks like in the real world. Think about a man named Arthur.
Okay, Arthur.
Arthur stood in the shadow of a shuttered textile mill in a deindustrialized corner of Ohio. The sky over his town was that permanent, bruised gray you only see in the Rust Belt. The silence in the streets was heavy enough to crush a man's ribs. It's the silence of a town where the central economic engine has been ripped out and shipped overseas.
That is a profoundly destabilizing environment.
So Arthur goes to his doctor because he can't get out of bed. He is experiencing persistent lethargy, brain fog, and a crushing, suffocating despair. And his doctor, trained in the biomedical model, looks at Arthur, checks off a list of symptoms on a clipboard, and tells him he has a brain chemistry imbalance.
Right, the standard diagnosis.
The doctor hands him a blister pack of antidepressants, a blister pack of hope. But as Arthur walked out of that clinic, past the vacant storefronts where his father and grandfather had earned their dignity, where they had built community, he knew the truth. He knew the imbalance wasn't microscopic, it wasn't in his synapses. The imbalance was in the streets.
The pills could artificially tweak his dopamine and serotonin, sure, but they couldn't reopen the factory. They couldn't restore the communal Friday nights at the local diner that once gave his life a rhythm and a sense of belonging.
Exactly. His brain was actually functioning perfectly. It was providing a completely rational, chemically appropriate response to a dismantled life. To suggest his pain was a biological glitch, a mere misfiring of neurons, was to profoundly insult the reality of his struggle. It ignored the glaring fact that his internal chemistry was merely the mirror reflecting a broken social landscape.
Arthur's reality highlights the worsening systemic crisis documented in modern medical literature. Let's look at the actual epidemiological data. A comprehensive analysis published by researcher Brett Deacon in 2013 detailed the paradoxical outcomes of this entire biomedical era.
Paradoxical how?
Well, since 1988, there has been a staggering 400% increase in antidepressant use in the United States.
400%?
Yes, 400%. Billions upon billions of dollars have been directed into neuroscience research, specifically hunting for these biological cures.
So, by any logical metric, if we are prescribing 400% more the cure and spending billions on the science, the population should be getting significantly healthier, right? Rates of depression and anxiety should be plummeting.
But the outcomes are entirely contrary to the promises of the biomedical model. Mental health outcomes in the industrialized world have dramatically worsened. Yes. Mental disorders have become increasingly chronic, severe, and disabling. The widespread application of biological labels and pharmacological interventions has presided over an undeniable public health disaster. The disease burden of depression and anxiety has escalated in direct correlation with the increased use of psychotropic medications.
This failure isn't just medical. It extends to the massive public relations efforts designed to alter societal perceptions. Think about the campaigns you've seen over the last 20 years. Organizations like the National Alliance on Mental Illness pushed the disease like any other narrative incredibly hard. The logic seemed sound at the time. If you tell the public that mental distress is just a genetic or biological defect, no different than asthma or diabetes, then the stigma would vanish. People wouldn't judge Arthur for being depressed. They would just see him as a guy with a faulty biological switch.
It was a well-intentioned campaign, but the sociological data proves it was a catastrophic miscalculation. Research by leading sociologists like Bernice Pesco-Salido and George Shomeras proves this campaign completely backfired.
Backfired how? Why would telling someone it's a disease make things worse?
Because of how human beings instinctively react to the concept of permanent biological defects. Telling the public that individuals with mental distress possess defective brain chemistry or genetic abnormalities actually increased the public's desire for social distance.
It scared people.
Precisely. It made the general public view those in distress as unpredictable, permanently damaged, or fundamentally other. If your sadness is a reaction to losing your job, I can empathize with that. I can put my arm around you. But if your sadness is a symptom of a fundamentally broken genetic brain structure, I unconsciously pull away.
Breaking.
And even worse, it made the patients themselves significantly more pessimistic about their own chances of recovery. If your distress is a reaction to your environment, you can change your environment. If your distress is coded into your DNA, you are trapped.
Interesting. If we tell people like Arthur that their profound, agonizing grief over losing their entire community is actually a lifelong, incurable brain disease, we strip them of all agency. We turn them into passive victims of their biology.
Right.
But even more insidiously, we've effectively absolved society of its responsibility to fix the shattered economy. We don't have to look at wealth inequality or lack of healthcare or the destruction of local communities. Instead, we just blame Arthur's neurobiology. The societal failure gets neatly repackaged as an individual medical defect.
This is exactly why the biomedical model failed. It attempted to find specific, localized biological causes for distress, deliberately ignoring what researchers call the everything problem in psychiatry.
The everything problem.
The biomedical model wants to find a specific pathway, like virus A causes disease B. But the epidemiological data shows that every single type of social adversity, whether it is extreme poverty, childhood physical abuse, chronic social inequality, racism, or discrimination, raises the risk for all types of mental health presentations.
So it's not a one-to-one ratio.
No, there's no specific linear pathway where one distinct trauma causes one distinct biological disease. Causality in human affairs is contingent, synergistic, and highly probabilistic.
So you can't say poverty causes low serotonin, which causes depression.
No. A societal failure, like extreme poverty, acts as a massive synergistic catalyst. It magnifies the impact of all other adversities and triggers a vast array of protective biological threat responses across a population.
Right.
One person might react to poverty with profound lethargy, another with extreme hypervigilance and anxiety, another with paranoia. Blaming the individual biology obscures the systemic operation of power and inequality that actually generates the distress.
So once we abandon this broken chemical imbalance theory and we recognize that our pain is a reaction to our environment, we are left staring at a blank slate. We need an entirely new framework to understand human distress, one that actually recognizes human survival, agency, and personal narrative. Let's look at a woman named Sarah. For a decade, Sarah had been bouncing around the psychiatric system, told repeatedly that her severe, paralyzing anxiety was a permanent biological defect. She had the broken brain label stamped on her file, but one afternoon she found herself in a community garden in the Pacific Northwest. Her hands were deep in the cold, damp earth. She was pulling up weeds, feeling the resistance of the roots, smelling the raw soil.
A deeply grounding, tactile experience.
Yes. For years, the narrative of chemical imbalance had stripped her of agency, making her a passive observer of her own brain's supposed malfunctions. Every time she felt a spike of panic, she thought, oh, there go my broken chemicals again. But in that garden, she started talking to people. She began the agonizing, brave work of narrative therapy. Right. She started unearthing the specific, jagged, painful memories of a childhood defined by extreme instability. Parents who were constantly fighting, evictions in the middle of the night, never knowing if she was safe.
She began to contextualize her biology.
Exactly. And as she finally connected her current physical panic to her past reality, the chemical noise in her head began to quiet. She discovered an empowering truth. Her brain wasn't broken at all. Her brain was hypervigilant because it had to be. It was a biological masterpiece of survival, perfectly tuned to keep her alive in a dangerous, unpredictable childhood.
That makes total sense.
As she slowly resolved the underlying life experiences and built a safe reality in the present, her physiology naturally followed suit. The panic attacks faded. She proved that the body's chemistry is the downstream effect of a life lived, not the source of it. Her healing didn't come from a bottle, but from the courageous act of reclaiming her story from the reductionist medical labels that had sought to simplify her complexity into a neat little formula.
Sarah's reclamation of her story perfectly illustrates the core methodology of the power-threat-meaning framework.
The PTM framework.
Yes. This is a revolutionary alternative conceptual system developed by clinical psychologists Lucy Johnstone and Mary Boyle. The PTM framework completely abandons the diagnostic medical model. It takes the fundamental pathologizing psychiatric question of what is wrong with you and throws it out the window.
Good riddance.
Exactly. Instead, it replaces it with 4 distinct, deeply human, critical questions.
Let's walk through these 4 questions because they are powerful tools anyone listening can use. What is the first one?
The first question is, what has happened to you? This isn't just asking for a timeline of traumas. It asks how power is operating in your life, and it breaks power down into specific categories. It encompasses embodied power, which is physical strength or violence. Legal power, like who controls the laws that govern you. Economic power, do you have access to resources, housing, a living wage? And ideological power, like what societal narratives are being forced upon you.
So, for Arthur, the economic power of the corporation leaving his town devastated his life. For Sarah, the embodied power of unpredictable parents shattered her safety. Once we know what happened and how power was wielded against them, what is the second question?
The second question is, how did it affect you? This identifies the specific threats posed by those power dynamics to your core human needs. We all have fundamental needs for physical safety, for secure emotional attachment, and for a sense of justice and belonging in our community. When power is abused, it threatens these core needs. What sense did you make of it? This explores the meaning. As humans, we are meaning-making machines. If a child is neglected, the meaning they often generate, heavily influenced by societal discourses, is "I am unlovable" or "I am inherently bad." The framework asks you to examine how society's beliefs have shaped your own deeply held feelings about your worth and your reality.
Which brings us to the final and perhaps most crucial question of the framework.
The fourth question, what did you have to do to survive? This identifies the specific threat responses you are actively employing to navigate the hostile environment you find yourself in.
This completely flips the script on what the medical model calls symptoms, doesn't it? Within the power threat meaning framework, these aren't symptoms of a broken brain. They are evolved, meaning-based threat responses. They are literally survival strategies.
Exactly. Let's look at behaviors traditionally labeled as severe psychiatric symptoms and apply this new lens. Take hearing voices.
Okay.
In the biomedical model, this is a hallucination caused by excessive dopamine, full stop. In the PTM framework, hearing voices is often an adaptive mechanism to process profound, unspeakable trauma.
That completely changes how you treat it.
Or take extreme paranoia. Paranoia is an entirely understandable, logical, adaptive response to an environment defined by persistent bullying, physical violence, or systemic, relentless discrimination. If the world is actually out to get you, hypervigilance isn't a disease, it's a shield.
Let's talk about restricted eating, like anorexia. The medical model treats it as a biological pathology. But under this framework, what is actually happening?
When an individual, often a young person, is trapped in an uncontrollable, abusive, or chaotic environment where they have zero agency over their life, restricted eating often serves as a desperate, highly logical mechanism to establish a sense of agency.
Trying to find control.
Exactly. I cannot control my parents, I cannot control my safety, but I can control exactly what enters my physical body. The behavior is not a manifestation of a diseased brain. It is a highly functional strategy employed by a nervous system fighting tooth and nail to survive a psychological threat.
So what does this all mean for you, the listener, as you navigate your own stress, your own anxiety, or your own periods of deep sadness? It's like realizing the check engine light flashing on your dashboard isn't the problem itself. The flashing light isn't a defect in the bulb. The light is an indicator that you are driving your car over a field of landmines.
Exactly.
The biomedical model tells you to smash the dashboard light with a hammer so you don't have to look at it anymore. The PTM framework tells you to look at the light, realize it's trying to save your life, and steer the car out of the minefield.
That is a phenomenal analogy. And this meta-framework also provides a profound, clarifying lens for understanding cross-cultural expressions of distress.
Because it's not the same everywhere.
No, the traditional diagnostic medical model, written almost entirely by Western psychiatrists, views any deviations from its specific criteria as primitive, unusual, or exotic. It labels them culture-bound syndromes.
As if only other cultures have unique ways of expressing pain, while the West has the objective biological truth.
The power thread meaning framework recognizes the reality. There are no culture-bound syndromes, because all expressions of human distress are bound by culture.
Point.
Western psychiatric diagnoses are just the culture-bound syndromes of late-stage capitalism. In Western industrial societies, our distress frequently manifests around our specific, ideologically driven expectations. We see massive emotional struggles related to the failure to fulfill wage labor roles, the intense media-driven pressure to conform to highly specific body image ideals, and the isolating mandate for hyper-individuation, the idea that you must be entirely self-sufficient and independent.
We isolate ourselves, we define our worth by our productivity, and then we wonder why our biology is screaming in agony. How does this compare to outcomes in other parts of the world?
Contrast the Western approach with outcomes in the global South. Long-term research consistently demonstrates a fascinating reality. Severe mental distress often has significantly better long-term recovery outcomes in non-industrialized areas.
Wait, places with less access to modern psychiatric hospitals and less access to SSRIs actually have better outcomes for severe distress?
Yes, because in many of these regions, local healing practices inherently operate closer to the PTM framework. They prioritize community integration. They rely on dense social support networks and shared narrative frameworks to make meaning of the pain.
They don't just hand you a pill and send you home alone.
Right. They address the threat and restore meaning collectively as a group. They do not medicalize the individual's reaction, isolate them in a clinic, strip them of their agency, and artificially suppress their biology with pharmaceuticals. They treat the person as a human reacting to life, not a broken machine.
The journey through the evidence we've taken today reveals a stark, undeniable reality. The chemical imbalance theory was a scientifically unfounded urban legend. It was a marketing triumph that fundamentally inverted our understanding of biology. The human brain is not a static, rudimentary machine requiring fluid adjustments. It is an exquisitely noisy, chaotic, and unimaginably adaptable organ that physically wires and rewires itself every single day to reflect our lived experiences. By shifting our perspective from a restrictive paradigm of disease to an empowering paradigm of meaning and survival, individuals can finally reclaim their agency. They can understand the profound logic of their threat responses, and they can begin the real work of rewriting their physiological reactions to the world.
The ultimate irony of the biomedical era is that in our desperate attempt to prove that emotional distress was a mechanical disease of the brain, we accidentally proved just how exquisitely the human nervous system is designed to experience the reality of being alive. Our pain, our despair, and our anxiety are not malfunctions of a broken machine. They are the absolute proof that our biology is working perfectly, stubbornly refusing to let us numb ourselves to the world we have built.